We'll start in about a minute. In Chapter 9, Section 7, we'll graph quadratic functions using transformations. So yesterday we graphed quadratic functions that were in standard form. So this first part is review. Let the variable y be a quadratic function of the variable x. Then its standard form is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. But every quadratic function, y equals ax squared plus bx plus c, can be written in vertex form. The vertex form is y equals a times the binomial x minus h squared plus k, where the ordered pair hk is the vertex. So that means the x-coordinate of the vertex is negative b over 2a. Hey, one nice thing about the vertex form, y equals a times x minus h to the second plus k. Well, if a is positive, the parabola opens up, and you can tell by looking at the vertex form what the x and y coordinates of the vertex are. So suppose we have a parabola that opens up, and the vertex is above the x-axis in this picture. So the x-coordinate of the vertex is the number that is subtracted from x inside the parentheses, and the y-coordinate of the vertex is the number that is added on the outside of the parentheses. So that's the vertex. Now you could have a parabola that opens downward, but if it's in vertex form, then you can tell by looking what the x and y coordinates of the vertex is. Okay, so the title of this is Graphing Quadratic Functions with Transformations. So the transformations involve a horizontal movement and a vertical movement. So if you have y equals x minus h quantity squared plus k, and if you begin with y equals a times x to the second, so suppose in this illustration that a is positive, so y equals ax squared has its vertex at the origin, at the point 0, 0. Then if you write y equals a times x minus h squared. Let's assume in this example that h is positive. Then the graph of y equals a times x minus h quantity squared can be found from the graph of y equals ax squared if we move this parabola h units to the right. So I think what I'll do is I'll get a bigger piece of paper just to illustrate what I'm trying to say here. So suppose we begin with y equals a times x to the second with a greater than 0. Then the graph of y equals ax to the second is a parabola. The vertex is at the origin. Then if we do a transformation, this time we'll look at y equals a times x minus h squared. And in this example, we'll assume that h is positive. So the graph of y equals a times the binomial x minus h squared can be found by moving the graph of this parabola h units to the right, because h is positive. So let's suppose this is the h. So this ordered pair is h0. Okay, then if we want to graph y equals a times x minus h squared plus k, and for this one we'll assume that k is positive, we can get a graph of y equals a times x minus h squared plus k if we move the graph of the previous parabola vertically upwards by k units. So here's where h is, but we're moving the parabola upwards by k units. So the vertex is hk. Okay, so this is what is meant by graphing a quadratic function using transformations. So this first one is a horizontal transformation, or another way to think of it is horizontal translation, or a horizontal movement. In this case, we move to the right because h is positive. And then the second one is a vertical translation. Hey, but the goal today is to learn how to rewrite a quadratic function from standard form into vertex form. So we'll look at a number of examples, and I'll show you step by step how to get a quadratic function into standard form. Okay, it's going to involve something that you have seen before, and also some fairly basic arithmetic. So the directions are rewrite quadratic functions from standard form, y equals ax squared plus bx plus c, to vertex form, y equals a times the binomial x minus h squared plus k, by completing the square. You know something about completing the square. We've done that a few times. And then we can sketch the graphs afterwards and find all intercepts. Okay, so this first one, y equals x squared plus 6x plus 8. Think of this as y equals 1 times x squared minus 6x, but I'm going to leave the plus 8 on the outside. So what I did, it's a little consequence in this one, but I factored 1 out of the x squared term and the minus 6x term. Factoring 1 out doesn't change anything, but I want you to get used to factoring the coefficient of x squared out of the x squared term and the x term, because we're not always going to have quadratic functions with a leading coefficient that's equal to 1. So factor 1 out of the x squared term and the minus 6x term, but leave the constant plus 8 outside of the parentheses. And then on the inside, we're going to add 0. When you add 0 to something, you don't change its value. But the form 0 takes is going to involve completing the square. So let's focus on x squared minus 6x. What number would I have to add to x squared minus 6x? What number would I have to add to that to get a perfect square trinomial? Hey, we've done this before. So we're just focusing on x squared minus 6x. We're ignoring this factor 1 that was factored out. So when we focus on x squared minus 6x, to create a perfect square trinomial, we take 1/2 of negative 6 and square that number. So 1/2 of negative 6 is negative 3. And when we square negative 3, we get positive 9. So I'm going to write plus 9 minus 9. So technically all I'm doing is adding 0. So I'm not changing the value, we're just changing the form. Okay, in the next step, we're going to keep the perfect square trinomial inside the parentheses, but we're going to move this 1 times negative 9 so that it's on the outside of the parentheses. I'm just using the distributive property on one of the numbers or one of the terms that's inside the parentheses. The first 3 terms are going to stay inside the parentheses. So I'll have 1 times the perfect square trinomial x squared minus 6x plus 9. But then we apply the distributive property to the 4th term. 1 times negative 9 is negative 9. So on the outside, we write minus 9 together with the plus 8 that's already on the outside. Or if it's easier for you, we can put the plus 8 first and then the minus 9 afterwards. Either way is okay. You just need to make sure that you're careful with the arithmetic. Okay, in the next step, we can write the the vertex form. The leading coefficient 1 is not necessary, so I'm going to omit it here. And then x squared minus 6x plus 9 is equal to x minus 3 squared. Because it's a perfect square trinomial, it's equal to some binomial squared. And then minus 9 plus 8 is minus 1. Okay, so the vertex three is the number that is subtracted from x on the inside of the parentheses. So 3 is the x-coordinate of the vertex. And the y-coordinate of the vertex is negative 1. So it's the number added on the outside. When we have minus 1, remember that's the same as adding negative 1. So that means the y-coordinate of the vertex is negative 1. Okay, this parabola opens upward, and the vertex is below the x-axis. It's at 3, negative 1. And we can find the x-intercepts. Well, to find the x-intercepts, we can just use the standard form. So find the x-intercepts. So what's the procedure for finding the x-intercepts? We can use the standard form or the vertex form to find the x-intercepts, but in either case, we replace y with 0 and then solve for x. So I'll write that as a reminder. Replace y with 0. And then solve for x. So if we use the standard form, replace y with 0, we get 0 equals x squared minus 6x plus 8. And we can always use the quadratic formula, but this time we can solve by factoring. The two factors are x minus 2 and x minus 4. The two solutions to this equation are positive 2 and positive 4. And so the x-intercepts, remember the x-intercepts are ordered pairs, so one x-intercept is 4, 0, the other one is 2, 0. And that is pretty much all the detail we need. We should find the y-intercept, though. The y-intercept is an ordered pair. The x-coordinate of the y-intercept is 0. So to find the y-intercept, or the y-coordinate of the y-intercept, just replace x with 0, either in the standard form or the vertex form. But the standard form is probably the easiest. Replace x with 0, we get y equals 8. Okay, so in my small graph, 0, 8 is sort of off the grid. Okay, let's look at the next quadratic function. This one, y equals 2x squared minus 16x plus 34. So let's get this into vertex form by completing the square. So this time the leading coefficient is positive 2. So we factor 2 out of the x squared term and the x term, but leave the constant plus 34 on the outside. So in other words, factor 2 out of the first two terms only. So we have 2 times the quantity x squared minus 8x. I'm going to leave some space for the adding 0 part, and then the plus 34 stays on the outside. Then we focus on the inside of the parentheses, the x squared minus 8x. And in this step, we're going to add 0, but in the process, we will create a perfect square trinomial. Okay, so the form that 0 takes this time, well, we want to add a number to x squared minus 8x to make it to get a perfect square trinomial. So we take half of negative 8, which is negative 4. Then we square negative 4. Squaring negative 4 gives us positive 16. So we write plus 16 minus 16. We're just adding 0. So we're not changing the meaning of the function, we're just changing the form of the function. Okay, in the next step, inside the parentheses, we're going to keep the perfect square trinomial, the x squared minus 8x plus 16. But in the fourth term above, we're going to multiply 2 times negative 16, which is negative 32. So on the outside of the parentheses, we're going to subtract 32 from the plus 34. And then the next step is we can write the vertex form in the next step. So we have 2 times a binomial squared. So x squared minus 8x plus 16 is equal to the binomial x minus 4 squared. And then on the outside of the parentheses, plus 34 minus 32 is plus 2. So now we know the x and y coordinates of the vertex. The x coordinate of the vertex is 4, positive 4. It's the number that we're subtracting from x on the inside. The y-coordinate of the vertex is positive 2. It's the number that we're adding on the outside of the parentheses. Okay, so this vertex is above the x-axis. The ordered pair of 4, 2 is above the x-axis. The parabola opens upward, so that means there are no x-intercepts. No x-intercepts. Every quadratic function has a y-intercept. When x is 0, the y-coordinate is 34. Okay, so to get a graph, we should find a couple more points on the graph. So we already found the vertex. So one thing we can do, we can put the ordered pair 4, 2 in our table of x and y coordinates. Pick an x value smaller than 4, like 3. You could pick 2 or something. Just pick something that will be on the grid, and then pick an x value bigger than 4, like 5. So since I chose 3 and 5, by symmetry, whatever the y-coordinate is that goes with 3 will be the y-coordinate that goes with 5 also, because we have symmetry. Okay, so let's find the y-coordinate when x is 3. So in the function, we can use the standard form or the vertex form. It looks like the vertex form might be easier. So in the vertex form, replace x with 3. So inside the parentheses, 3 minus 4 is -1, but -1 squared is +1. 2 times +1 is 2. 2 plus 2 is 4. We're going to get the same y-coordinate for x equals 5. But let's go ahead and replace x with 5 in the vertex form. When x is 5, 5 minus 4 is 1. 1 to the second is 1. 2 times 1 is 2. 2 plus 2 is 4. Just as we expected. Okay, so we can get a rough sketch of this parabola. Hey, the vertex 3, 4. The ordered pair 4, 2. Wait. Sorry. 4, 2 is the vertex. So 3, 4 is on the graph. 4, 2 is down here. So I sort of botched that graph. 5, 4 is up here. So we get our parabola. Okay. We'll move on to some more examples. One more easy one, and then after that we'll get some that are a little bit more challenging. So here we have a quadratic function in standard form, y equals 3x squared plus 30x plus 72. We want to get it into vertex form. So I'll give you a minute or so to work out the details for the vertex form. Okay, did you get an answer? Okay, so the coefficient of x squared is 3. So factor 3 out of the first two terms, but leave the constant plus 72 on the outside. So we factor 3 out of 3x squared plus 30x, and we get 3 times the quantity x squared plus 10x. Leave some space, and then put plus 72 on the outside. So in the next step, we add 0 on the inside of the parentheses. So now we focus on the x squared plus 10x. To complete the square, or to create a perfect square trinomial, we take half of 10 and square it. 1/2 of 10 is 5. 5 squared is 25. So when we add 0, we put plus 25 minus 25. Okay, in the next step, we're going to keep the perfect square trinomial on the inside of the parentheses. And so we'll get 3 times the quantity x squared plus 10x plus 25. But then we apply the distributive property to the fourth term up here. 3 times negative 25 is negative 75. So that means on the outside of the parentheses, we put a minus 75 together with the plus 72 that's already on the outside. The next step is we can write the vertex form in the next step. X squared plus 10x plus 25 is a perfect square trinomial. So it's equal to the binomial x plus 5's quantity squared. And then the plus 72 minus 75 simplifies to minus 3. Okay, so what are the x and y coordinates of the vertex for this parabola?
5 and -3.
How much?
5 and -3.
Well, remember the x coordinate of the vertex is the number subtracted from x on the inside. So x plus 5 is equivalent to x minus negative 5. So we don't write x minus negative 5, but that's what we're thinking. So the x coordinate of the vertex is negative 5. And the y coordinate is, in this case, negative 3. The way it was described to begin with was that the y coordinate is the number added on the outside, but subtracting 3 is equivalent to adding negative 3. So a way to rewrite this is 3 times x minus the number negative 5 squared, and then minus 3 is equivalent to adding negative 3. We don't want to write it, we don't want this to be our final result, because we should simplify the x minus negative 5 to x plus 5. And we should simplify plus negative 3 to minus 3. But this is more true to the form y equals a times x minus h squared plus k. But we want to follow the ordinary conventions of arithmetic and simplify where possible. Okay, the vertex is below the x-axis. -5, -3 is below the x-axis. The parabola opens upward, so there are going to be two x-intercepts. So let's find the x-intercepts. So the procedure for finding x-intercepts. We replace y with 0 and then solve for x. So replace y with 0, we get 0 equals 3x squared plus 30x plus 72. It's okay if you want to apply the quadratic formula to this equation, but we can get rid of some of the clutter that's in the way if we divide every term on both sides by 3. So this is an ordinary quadratic equation. We replace the variable y with a specific number. So we can do things with the equation that we were not permitted to do with the function. So if you're just dealing with the function, we're not permitted to get rid of the factor 3. But if you replace y with a number, then you can just follow the ordinary rules for solving equations. So we'll divide every term on both sides by 3, and we get 0 equals x squared plus 10x plus 24. So it looks like we can solve by factoring. What are the two factors? X plus 6 and x plus 4. And you can verify by looking. 6 times 4 is 24, and 6 plus 4 is 10. So the equation has two solutions, -6 and -4. So the x-intercepts are ordered pairs. So up here, let's write the x-intercepts as ordered pairs, -6, 0, and -4, 0. Okay, so I'll try to squeeze in a graph. So -5, -3. This is the vertex. -6, 0, and -4, 0 are the x-intercepts. So there's our parabola. Okay, the next example, y equals -x squared minus 8x minus 12. Okay, so what's one thing we know about the graph of this quadratic function, other than it's a parabola?
It's gonna open upside down.
Yeah, this parabola will open downwards because the coefficient of x squared is -1. Okay, so To get it into vertex form, we're going to factor -1 out of the x squared term and the x term, but we'll leave the -12 on the outside. So I'll write -1 times the quantity x squared plus 8x. And then I'll leave some space and put a right parenthesis and then the -12 on the outside. Okay, the next step is the adding 0 step on the inside of the parentheses. So now we're focusing on x squared plus 8x. And we want to add a number to x squared plus 8x so that we get a perfect square trinomial. Okay, so half of 8 is 4. 4 squared is 16. So we write plus 16 minus 16. Then in the next step, we're going to keep the perfect square trinomial inside the parentheses, x squared plus 8x plus 16. And what are we going to put on the outside of the parentheses? Yeah, we already have a -12, so we'll put the -12, and then -1 times -16 is positive 16, which goes on the outside. Okay, then we can write the vertex form, -1 times the binomial x plus 4 squared, and then -12 plus 16 simplifies to plus 4. Okay, so someone online type in what the vertex is. It's an ordered pair. Which ordered pair? So does anybody on YouTube know the answer? Okay, there's one. -4 for x and +4 for y. That's correct. Okay, so this vertex, -4, 4, is above the x-axis. The y-coordinate is positive, so it's above the x-axis. The parabola opens downward, so that means there are 2 x-intercepts. Okay, let's find the y-intercept first. When x is 0, the y-coordinate is -12. And then find the x-intercepts. So in general, replace y with 0 and then solve for x. So let's use the vertex form this time to find the x-intercepts. So replace y with 0, so we get 0 equals -1 times x plus 4 squared plus 4. Then we can add 1 times x plus 4 squared to both sides. So 1 times x plus 4 squared equals 4. So in the next step, I'm going to ignore the factor 1, since that doesn't change anything. But if we have x plus 4 quantity squared equals 4, we can use the square root property to solve. So x plus 4 quantity squared equals 4, we write x plus 4 equals positive and negative square root of 4. The square root of 4 simplifies to 2, so we can write x equals negative 4 plus and minus 2. So one of the numbers, negative 4 minus 2, is negative 6. The other number is negative 4 plus 2, which is negative 2. Okay, so as ordered pairs, the x-intercepts are negative 6, 0, and negative 2, 0. Okay, let's go ahead and sketch the parabola. Negative 4, 4 is the vertex. Negative 4, 4. One x-intercept is at negative 6, 0. The other x-intercept is at negative 2, 0. And we know the parabola opens down. So the y-intercept is sort of off the grid. Okay, for the next one, let's just get the next two in vertex form. If we have about 3 minutes, and then we'll save graphing them until tomorrow, or we'll just move on to other problems tomorrow. But to get this into vertex form, we factor negative 2 out of the x squared term and the x term. So negative 2 times x squared plus 4x, but leave the minus 10 on the outside as usual. Then the next step is the adding 0 on the inside of the parentheses step. So now we're just focused on the x squared plus 4x. To get a perfect square trinomial, we take half of 4 and square it. Half of 4 is 2, 2 squared is 4. So on the inside, we write plus 4 minus 4. Okay, in the next step, negative 2 times the perfect square trinomial, x squared plus 4x plus 4. And then negative 2 times negative 4 is positive 8. So we write a plus 8 on the outside of the parentheses that goes with the minus 10 that's already on the outside of the parentheses. And then the next step is the vertex form. Negative 2 times the binomial x plus 2 squared. And then minus 10 plus 8 is minus 2. So the vertex well, on the inside of the parentheses, x plus 2, that's equivalent to x minus negative 2. So the x coordinate of the vertex is negative 2. On the outside of the parentheses, we have -2. That's equivalent to adding -2. So -2 is the y coordinate of the vertex. Okay, so how many x-intercepts are there? Yeah, there are no x-intercepts. The vertex, we only have a few seconds, but the vertex is below the x-axis. And since the leading coefficient is negative, we know the parabola opens downward. So there are no x-intercepts. Okay, it's time to quit. Tomorrow we'll do more of the same. But that's all for today.